Next, I want to talk about how we calculate the mean, variance, and standard deviation of a probability distribution. So to find the mean of a probability distribution, what you need to do is you need to take the sum, okay, that's what the summation symbol means, right? The sum of each random variable, x, and multiplying it by the probability that's going to occur. So in this example right here, this is when we were flipping 2 coins and counting heads from our previous video. The probability of getting 0 heads was 1/4, the probability of getting 1 head was 1/2, and the probability of getting 2 heads was 1/4. That means our mean is 1. Note, in this case, the mean is one of the values of x, but that doesn't have to be the case. In fact, it's actually rarely the case. Most often, the value of x will not be one of our discrete random variables. To calculate variance, also denoted as sigma, which is our standard deviation squared, what we do is we take the sum of our x values minus the mean times the squared times the probability. So the probability of getting 0 heads had a mean of 1. We multiply that by 1/4. The probability of getting 1 head had a mean of 1, and we multiply that by 1/2. The number of times we got 2 minus our mean was 1/4. So that would give us a sum of 1/2. Now, our standard deviation is the square root of 1/2, which is 0.707. How do we identify unusual results? So it's important to know, and I'm going to talk about this in the next slide as well, that any outcome that is more than 2 standard deviations from the mean is considered unusual. It's considered unlikely to happen. Any probability associated with an event that is less than 0.05 is considered unusual, and any event probability associated with an event that is less than 0.01 is considered very unusual. Let's talk about expected value. So expected value is really the mean of a probability distribution, and you can see that this formula looks really similar to how we calculated the mean before.